In this example, we have additionally connected a push switch. The LED is connected to the same GPIO pin like in our previous examples. The aim of this example is to turn on the LED only when the push switch is in the pressed state. For additionally connecting the push switch, we are using a breadboard also in this circuit. The push switch is connected to the GPIO pin number 2, GPIO pin 2. It's the physical pin number 3, that is 1, 2, 3, physical pin number 3. The GPIO pin 2 has an internal pull-up resistor, and so there is no need to connect any external resistors for pull-up. And by default, it's in the pulled-up state always. So actually what happens when we press the push button is this GPIO pin number 2 will get grounded through this push switch. And the logic behind our code is to continuously detect whether the GPIO pin number 2 will become low or not. So when the push button is pressed, the GPIO pin 2 will become low. And this is the logic of this program. We can see the program code now. So after importing the libraries, the LED pin, like in our previous examples, is defined to the GPIO pin 17, and the button, the new button, is connected to pin GPIO 2. So it is assigned to GPIO 2, and the LED pin is set as in the output mode, that is GPIO.OUT. And for the button actually the button is connected in the GPIO pin number 2, and it should be set as an input pin because we are reading some state changes of this pin. So it must be configured as an input pin. For that we will use GPIO.in format, this parameter. This will set the pin as an input pin. And this while loop will continuously checks or polls the button pin whether it has become low or not. So as I have mentioned earlier, when we press the button, the corresponding pin, that is the pin number GPIO 2, will get grounded through the button, and this while loop will detect that. So when this condition satisfies, that is button equal to GPIO.LOW, when we press the button it will become low, the corresponding action will take place, that is the LED will glow. This is the statement to turn on the LED. This is the same we used in our previous examples. And if it is not satisfied, this condition is not satisfied, it will come to the else part only, and here the LED will be off always. And 2 corresponding messages are also there. If the button is we press the button and the corresponding GPIO 2 is in the low state, then it will print like button was pushed. If not, it will print like the button was released. And this everything will continuously happen in a while loop as long as the while condition is true. And 1 second sleep is also given, delay function. 1 second delay will also given in between. So we can write the program first and see that in action. So this is the program. This is the same program we saw in the slide. So after writing the program, you can save it by pressing the Ctrl and O button, and exit by pressing Ctrl and X button. After that we can try running the program by giving Python and the name of the file, that is button.py in our case. I will give this program in the description section of this tutorial so that you can just copy it from there and paste in your file. So we can try running your program now. I am pressing the enter, going to press the enter now, and you can see that this message is continuously getting, that is the button was released, because at this time we have not pressed the push button yet. We can now try pressing the button now. So when we press the button, it will detect the change of the state of GPIO 2 button pin, and the LED will glow, and the message also here will change as button was pushed. So when we release the button press, it will go back to the previous state, that is the LED will turn off and the message will also change. It will become as button was released. So this is how you can read the input state of a particular GPIO port. In this example we have just used a simple push button to demonstrate that. You can try this in your lab, and if you have any doubts, please comment below.